Testing categorical probability two-way table. In this problem, we have a population. In this case, a social scientist wants to determine whether the marital status, divorce or no divorce of U.S. men is independent of the religious affiliation or lack thereof. A sample of 500, that is my population, all men in the United States. That is my population. We are going to take a simple random sample, or a random sample of 500 men in the United States, and we are going to survey these 500 people, men. And the result is tabulated as shown, because we want to study two variables, in this case, marital status and religious affiliation. Then we have two variables. The first variable, marital status, have two levels, divorce and married. That is my first variable. And my second variable, Y, have religious affiliation, have 1, 2, 3, 4, 5 levels. 2, 3, 4, 5 levels. Then this is a contingency table or two-way table. It's a two-way table. What is the idea? Actually, from each member of this sample, we are going to ask two questions. First question, what is your marital status, divorce or married, and never married or never married? And the second question, what is your religious affiliation? Could be A, B, C, D, or none. Two variables. Then we are going, according to these two answers, we are going to classify all of these 500 men into these cells. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cells. We are going to classify all of them into these 10 cells according to the answer for each people, for each person. Then, first question. Test to see whether there is a sufficient evidence to indicate that the marital status of men who have been or are currently married is independent on religious affiliation. What is the meaning of that? Listen, if we sum all men that are divorced, we have divorced and married. If we sum all of these numbers here, we have a total that is 160. And the total men that are married is 384. This total is 500 people. Then actually we can obtain the proportion of men that are divorced in this sample. What is the proportion of men divorced? 116 divided by 500. That is the proportion of divorced men. Then we want to know if this proportion of divorced men is not affected by this affiliation. They could be affiliated to this group, religious group, or this other, or none. If this proportion actually is the same in all groups, we can say, listen, the religious affiliation doesn't affect the percentage of divorce, or the religion's affiliation doesn't affect the marital status of those men. That is the test that we are going to do. We are going to test that marital status and religious affiliation, these two variables, are independent. It means that the proportion of each one, they don't affect each other, okay? Then how can we do this study? First of all, remember, do this problem using technology. Let's do this problem using StatCrunch. You can obtain this value in StatCrunch. This is my data. This is the data of two-way table or contingency table. The name of this table is two-way table because we are going to classify these 500 people in two ways, according to the marital status and according to the religious affiliation. Actually, if we sum all of these numbers here, this total, and this total, if we sum all of these, the total will be 500. And if we sum all number into these cells, also will be 500. This is a two ways to classify these 500 men, according to religious affiliation and according to the marital status. Okay, let's do this problem. How can we do this problem? It's very easy. Go to Stat. In this case, we have to we can go to goodness of fit, because goodness of fit is when we have one-way table, only one variable. Here, because we have two variables, we need to go to this section table. And in table, Stat table, go to contingency table, two-way table or contingency table. Then we have the summary. And in this table, we need to identify in which column are located all my data. My data are located in column A, B, C, D, and none. Column A, B, C, D, and none. In all of these columns are located my data. And in which column are located my label for the second variable, marital status. That is my second variable, located in this column. Okay, then we want to display expected count. the expected value, assuming that the percentage of divorce is not affected by the marital status, the political, the religious affiliation. And let's select this test, chi-square test for independence, and compute. That's it. We have everything. We have everything. We have all answers. We have my test statistic. We have the degree of freedom. We have the p-value. This p-value is 12. It's big. When my p-value is bigger than alpha, we have insufficient evidence to reject the null, to reject the assumption. Actually, we must conclude at the end that the marital status is independent of the religious affiliation. Is not affected by the religion affiliation. That is the conclusion when we see this p-value. When we see this p-value bigger than alpha, I don't know what is the alpha in this problem. If alpha is 5%, it's bigger. For alpha 0.5%, my p-value is bigger, then we have insufficient evidence. My expectation is the degree of freedom. The degree of freedom in this case will be 4. When my p-value is big, is because my evidence fall, that is the p-value, fall close to my expectation. 0.12 is bigger than alpha. Alpha should be a small value, 5%, 1%. Then that is the conclusion. Also here we have the expected value. All of this value is the expected value, assuming that the proportion 116 over 500, this proportion could be the same in all of these groups. It's not affected by this religious group. That is the expected value, assuming that the proportion is the same. Okay, then we have everything. How can we obtain this number? Using Excel. Let's do it. Let's find all of this number in Excel. That is the data. Two-way table, contingency table, when we have two variables, marital status and religious affiliation. Then first of all, we need to find the sum of all row, all column, all row, and all column. How can we find the sum of this column? Is equal sum of these two values. And we can copy this sum in all of these columns. How can we obtain the sum for this row? Is equal the sum of this row. And we can copy this formula in the second row also. We have all sum. We verify that this sum is equal 500 and this sum is also equal 500. Perfect. Then that is the observed value. That is the actual value. What is my expected value? What is the proportion? What is the proportion of divorced men? Is 116 out of 500. I am expecting this percentage or this proportion of divorced men into each group, into each of these groups, assuming that this proportion is not affected by the religion group. The first group consists in 211. If I multiply this proportion times 211, I will obtain my expected proportion of divorced men in this group. Actually, this is equal 116 times 211 divided by 500. And this is the formula that we are going to use. The expected value for any cell in row E and column J is given by the sum of the row, that is the row 1. Actually, the value located here, that the value that I am going to write here, will be equal 116 divided by 500, that is the proportion of divorced men, multiplied by the total men in this group, that is the total column 1. The total column 1. The expected value cells 1, the cells located here, row 1, column 1, is given the total column 1 times the total row 1 times the total column 1 divided by the total people that participate in this study. That is the formula for all of them. Then let's compute this formula in the first cell. Is equal row 1, and let's erase also this, is equal row 1 times total row 1 times total column 1 divided by the total observation. That is the expected number of divorced men in these 211 men from this group. What is the expected proportion of married men? The proportion of married men in 500 people is obtained by 384 divided by 500. That is the proportion of married men. This proportion is not, we are going to assume that it's not affected by the religious affiliation. Then for 200 men, in this case, for these 200, the expected value will be given by this formula. Actually, is equal row 2 times column 1 divided by 500. What is my expected value in this first row, second column? Is equal this total sum first row times total sum second column divided by the total. What is the expected value in the second row, second column? Is equal total row 2 times total column 2 divided by the grand total. We can continue doing that in all of this. If this, in this case, you can do it in this way. You can continue doing this in this, but if your table is so big, I recommend to continue doing that in this way. But if the table is so big, we have more levels for each variable, then I recommend to use this formula. Then the same formula, but in the first, we are going to fix 211 in this column. We need to fix G3. We are going, no, G3 is located here, 116. We need to fix this column. Then we need to fix the column G and time B5. B5 is located here. We need to fix the row 5. And we need to divide by always this number. We need to fix both row and column. That is the formula, but it's a little complicated. You can do it in this way, but I recommend to continue doing multiplying total row, total column, divided by the grand total. Or you can apply this formula to all of these. Listen, if we copy this formula here, we will obtain the same value. Can you see? If we copy this formula in these two cells, we are going to obtain the same value. And we can copy this formula in all of these to obtain all expected value very quick. We need to verify is this, let's copy this formula here because it's the sum of these two values. And we can copy this sum in all of these columns. And we verify, we can copy this sum in this order, and we verify that the sum of all of these expected value is 116, and the sum of this column is 80, and so on. The sum of all of this value is 500. How can we obtain my test statistic? Then my test statistic, let's erase all of this. My test statistic will measure the difference between my observed value and all observed value and the expected value. This test statistic will be chi-squared. We are going to obtain the difference between the observed value in the cells E, J, row E, column J, minus the corresponding expected value in the same position, because this difference could be positive or negative, and we want to sum all of these difference. We need to square to transform this in positive, and we are going to divide this by the expected value. This statistic will measure the difference between the observed and the expected value, and we are going to sum all of these quotient. Let's do this. Let's apply this formula in this cell. Actually, this will be equal let's open parentheses, the observed value minus the expected value squared divided by the expected value. Then we can copy our problem, this formula, in all of these cells, and we compute the test statistic for all of these cells using all of these cells. But we need the sum of all of these ratios. How can we obtain the sum of all of these ratios? Sum, open parentheses, we need to sum all value in all of these cells, close parentheses, and this is my test statistic. That is the value that we obtain in my can you see here? 7.13 is the test statistic, and the p-value is 12%. We are going to obtain the p-value later, and also we have all of this value. Listen, we obtained already all expected value. Can you see? 48 is the first one. Let's see it here. Can you see? 48.952, and the second is 18.56, 18.56. We have everything there using Excel. Okay, that is the first step. You have to resolve the problem using StatCrunch, and you need to verify all of these numbers using Excel. And let's show your work. How can you show your work? Then first of all, that is the data in Excel. You need to complete the sum of all columns and rows, and we need to compute the expected value for each cell. And when we compute the expected value for each cell, applying this formula, the total sum of this row, or the total in this row times the total in this column divided by 500, we will obtain all of these numbers. And also we need to compute the test statistic using this other table. We compute this formula. Here, we apply this formula for each of these cells, and we sum all of this value to obtain my test statistic, and let's show you work. Then the first step is to calculate estimated expected cell frequency under the assumption that the classification are independent. Rather, we use a SAS or we use a StatCrunch to obtain the answer, and it's given all the expected value, it's given everything, Then, because all my expected values, here we have all expected values. All of these values are my expected values. Because all of these expected values are greater, all expected values are greater than 5, then my sample was big enough. For that reason, we can use chi-square, and my expectation will follow this distribution. We can use chi-square in this to solve this problem, only because all my expected values are greater than 5. Then let's let's show your work to compute the expected value. You need to write this formula, and you need to compute the expected value for each of these numbers. You can do it in this way. You can give me the first one, the second one, and the last one. Only 3 is enough. Then the null and the alternative hypothesis. The null hypothesis is actually these two variables, marital status and religious affiliation, are independent. They don't interact each other. That is the null hypothesis. The marital status of U.S. men and their religion affiliation are independent. The alternative is the contrary. The marital status men and the religious affiliation are dependent, is affected. Then how can we show your work? The test statistic is given by this formula, and we need to write down all operations. We need to indicate all operations to obtain 7.1. Then what is the indication? We need to compute all of this. We need to indicate all of these operations written. The first value, 39, minus the expected value in this cell, square divided by the expected value, 48, plus the expected value in the second cell, and so on. You need to indicate that. You have done this in Excel. The only thing that you have to do to show your work is indicate all of these operations, and you need to write those answers. You don't have to write all of them, the first two and the last one, and this is equal 7.1354. That is show your work. If you paste this result, this Excel table, this Excel worksheet in my stat lab, will be considered extra credit, okay? But that is your work. That is your work. Then the test statistic 7.135 is far away from my expectation. Remember, the degree of freedom in this case is given by this formula, because we have two categories for marital. We have two categories for marital status, 2, 1, 2, and 1, 2, 3, 4, 5 category for religion affiliation. Then the degree of freedom is given by, we need to multiply 5 times 2 to obtain 10 value, but we don't have 10 value here. There are two restrictions, because the restriction for my first category is the sum of all of these value must be 500. We need to subtract one restriction, time the same thing for the second variable. The sum of all of the values should be also equal 500. We need to subtract one restriction for this, and we need to multiply this. Then this is equal 1 times 4. When we multiply this, the degree of freedom is 4. The formula for the degree of freedom is the number of columns minus 1 times the number of row minus 1. That will be the degree of freedom. That is the formula. The test statistic 7.135 is my evidence condensed in one statistic. Is highlighted in the bottom of the printout, and is observed significant, and it observes significant level. The p-value, the probability to get this value, one value more extreme, is also given, was 0.12. It's high, it's 12%. Then we fail to reject the null, and that is, we cannot conclude that the marital status of U.S. men depends on their religious affiliation. That is our conclusion. We can obtain the same conclusion from the beginning, but we need to show your work. And how can we obtain the p-value? Actually, we can use table, or we can use technology to obtain the p-value. This p-value could be obtained if you go, let's do it in StatCrunch. The p-value, this p-value, you have to go to stat calculator and go to chi-square, and in chi-square you need to enter the degree of freedom. The degree of freedom was 4, remember. 500. And my test statistic was 7 point. Let me see what is my test statistic. My test statistic was 7 point. It's greater than. The p-value should be the probability that my test statistic is greater than 7.1354642. If we compute that, we obtain exactly the p-value. Probability to get one value equal to my evidence or more extreme. Then this p-value is big. That indicates that my expectation in this distribution is 4. One value close to 4 or smaller than 4 when the two variables are independent. That is my expectation. For that reason, we got a value pretty close to 4, actually 7. We have insufficient evidence to reject the assumption. That is our conclusion. Also, we can obtain this in the table. In the table, let's see, formulas and table. In this table, that is the chi-square table. For 4 degrees of freedom, 7.1 is located between these two numbers. In this degree of freedom, 7.1 is located here. Actually, what is the tail? Remember, this in this table, all of these numbers are the critical value associated with this tail. The tail is given in this row. If the value is located between these, then no, it's here. 7.1 is between these two numbers because 7.1 must be here because the critical value are increasing in this row, increasing. Then 7.1 must be here. Then my the tail for 7.1 must be greater than 0.10 because you can observe here that the tail, the area on the tail is increasing for all of these numbers. Then it's bigger than 0.10. Actually, it's 0.12. It's another way to use table to prove that the p-value is greater than alpha. Suppose that alpha is 5%, my p-value is greater than alpha according to this table. But we can use technology to find the exact value. And let's stop here. Let me see if we have something else. Yes, I would like to explain something else. Then part B. Part B is the marital status. Actually, listen. We can verify that the marital status, the proportion for divorced men is given 116 divided by 500. Actually, it's 23%. In this group of men, the proportion of divorced men is 23%. 23%. Then if these variables are independent, they don't affect each other, then this proportion must be the same inside all of this group of men. That is the null hypothesis. No, these two variables are independent. Then we expect 23% value in all of these cells. Let's verify that one. 23% is the total percentage of divorced men. And let's verify what is the percentage of this value respect to 211 is 18%. And in the second group of men, we have 80 men in this group. We expect 23% of divorced men. We got 24. And in the other group, 21. Actually, this is a sample. This sample, we don't have enough evidence using this sample to state that this proportion is different in all these groups. Actually, it's pretty close to 23, pretty close. That is insufficient evidence to state that the religion affiliation could affect the marital status. And we can verify this also using analyzing these two tables. This is the expected value. This is assuming that this proportion is not affected. It's the exact value. When we obtain 23% of 211, we obtain this value. 23% of 80 people is 18 people, and so on. So we can obtain actually this expected value multiplying total column, and divided by 500. And also we can obtain the expected value in the cells 1, row 1, multiplying 23% times 211. Is the way to understand. Analyzing these two tables, you can understand this problem and the objective in this problem. And that's it. This graph also, in this graph, we can observe that actually it's not affected. These two variables are independent. Let's stop here.